Alright, so ironically I made a video about arrays and pointers in C, and it was called The Last Video You'll Ever Need to Watch on Arrays and Pointers in C. And, of course, I forgot one format of an array that I wanted to explain. But hey, you know what? I never claim to be perfect, so let's cover it right now. We're going to make a quick little addendum video. So, watch the other video first. I'm going to put the link in the description, and I might even pop it up on the screen right now if YouTube still lets me do that. But you can see right here we have a character array, and we're not putting the number of elements we want because C can infer how many elements we want from the elements specified. So basically, in a nutshell, in the last video we did this. We did something like this. We did char, my array, and then we went like that, and then we said equals, this is my array, right? And in this case, this is legal to do. What goes on is C automatically takes and creates an array that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and then 18. So it takes whatever we have here, it adds one more to it, and it places a null terminator in that spot. And then it creates a buffer. So you can go ahead, remember that. You can go ahead and you can do something like my array 0, if you want to change the first T in the sentence there, equals U. And that's legal. Why? Because this is actually a buffer. This is not stored in read-only memory. So it turns out that this right here, what we just did today now, is also very similar. So in order to not confuse you, I'm actually just going to delete. So this is all we got now. So this is actually very similar to what we just did above, right? This is still an array. It's still a buffer. It's not in read-only memory like a char star is. So like when we go like this, char star my read-only equals this is in read-only memory. Now we can't change this. We can't do my read-only 2 equals A because that's why it's read-only. So it's just not going to work. It's going to crash. So that's that. Now this one here is basically the same thing as declaring my array like this, or my array like we did above before. So it's an actual array. It's not read-only. And however, there's a small difference here that I want to explain. Yes, this is going to it's going to set aside the number of char elements needed or bytes needed for every single one of these elements here. So obviously we have 6 elements in total. So it's going to create initialized array to be size 6. Now, what I want you to know, though, is that I put this null terminator here because when you do it like this, it's not going to do it for you automatically. So I had to put it here. So that way when I read or I print the array as a string, which basically all a string means is take a character array, start at element 0, and continue until we hit a null terminator. So without a null terminator, there's nothing telling this string to end, so it can just kind of go into the abyss or hit other data that we don't want until it hits some form of a null terminator at some point. And so when you initialize an array like this, it's not automatically going to put an null terminator for you. And that's fine because maybe you don't actually want to read this as a string, right? So in other words, maybe you're not going to do this right here, as you can see. Let's just comment that out. That's actually not even a proper C comment, but we'll just pretend it is. So let's comment that out. And maybe all we're going to do with this array is we're going to say initialized array 2 equals A here, and then maybe we're going to do initialized array 4 equals C. And that's all we're going to do with this array. And then we're just going to read out, you know, each thing individually. You know, like maybe we're going to do printf, you know, the second letter is, and then we're going to do %C for char. And then we're just going to do like initialized array 1, because the second letter is actually 1 since we started at 0. And so all this is going to do is just going to print out whatever letter is in this position right here, which is E in this case. All right. So if we're only doing that, then we don't need a null terminator because we're not reading it as a string, so it doesn't really matter. We're never actually going to, you know, blow out the end of it. But if we are doing stuff like this here, where we're actually trying to print it out as a string, notice the %s there, then it's going to keep printing until it hits that null terminator. And so in that case, we're going to want to put a null terminator up here, because when you do it, when you initialize the array in this format here, it doesn't automatically put the null terminator for you, because it's really what you're doing is you're creating a true character array here rather than a string per se. But you can make it a string by putting this null terminator there. So that's what I wanted to. That's the main lesson I wanted you to get out of this. And of course, none of these arrays don't have to be chars. They can be like, you know, they could be integers as well. Same kind of syntax. You know, 22, 25, 56, 75, 87. See. So here what we've done is we created an array that has 5 elements, all of which are integers, and we could refer to these integers. Say we wanted 87, we could do, you know, my int array 4, that would give us 87, because the fifth, again, we start at 0. So this is the lesson for today that I wanted to describe. Now what I'll do is I'll go ahead and I'll just print this out so you can see what I'm talking about. Well, actually, I already printed it before I did this change, but I'm going to go ahead and do the change now and then print it out. And we'll be good to go. See if anything happens. All right. So see, you can see how it says TC. Basically, it took test and I modified it. I put an A in the third position. So you can see TEA right here. Replace the S. And then I put a C in the fourth position, or the fifth position. So 0, 1, 2, 3, 4. So that replaced the new line there. And then, like, let's say now I don't know what's going to happen. It's technically, I guess, undefined behavior. But basically, if I try to print this as a string and I don't have a null terminator, it might very well just stop at the same letter, or it might not. I don't really know what's going to happen. So let's just give it a shot, see what happens. It might print some junk. See, there we go. See, it printed some junk. You can see how there's like this strange character printed there. So it's not good. Undefined behavior. Okay, so that's the lesson for today. And that, coupled with the previous video, should really be pretty much all you need to know about pointers in C. There are other things like pointers to pointers and pointers to pointers to pointers and all that, which we can cover in a future lesson, but this is pretty much all the fundamentals. All right, take care. Oh, one more thing too, real quick, which I want to mention is you can go ahead and you can refer to an array of that sort in the same way as you would before. So if you, let's say you wanted to create a pointer to that array, you could do char star, you know, my pointer equals initialized array, or you could do char star my pointer 2 equals initialized array, or address of initialized array 0. So you want the address of the first element, and I'll go ahead and build the program so you can see I'm not making stuff up. See, it builds. And so if you wanted to pass in this array to a function which took a you know, character array or a character pointer or char star, you could pass it in as just either the address of the first element, or you could pass it in as just initialized array to the function. All right, thank you for watching, and I will see you next time. Don't forget to subscribe.